Let's start with the hackathon. Today will be the last hackathon of the school, and today we are going to play a bit with the agent. So what we propose to you is just to create, or maybe better to say adjust, improve one simplistic agent that we prepare. So let's start with the introduction of the notebook. For that, we need to go to the GitHub folder of the school and to the day 4. And in the day 4, there is a 4 p.m. hackathon. So for this hackathon, you will not need to use GPU. And the idea will be the following. So first of all, it will be a very simple agent, which will be used Gemini as a reasoning core. And it will build with a simplistic framework provided by Hugging Face. It's called smolagents. So what should we do? Okay, somebody. It looks like somebody captures this. It is not my screenshot. Yeah, no. Okay. No, this is mine. Okay, nice. So the first thing we need to do, we just need to connect it. So I recommend you probably to spend 2-3 minutes to go through some documentation about a small agent framework. So it is very simplistic, but at the same time, for example, Levi, who presented at the first day, the agent which was able to call and control the instrument, was also built based on this framework. I would say that for more serious agents, more serious work, you may consider more complex solution, but just to try and get comfortable with the agentic workflow, small agent can be one of the good choice. So let's go through the cell. Everything is pretty standard. We install libraries, then we upload several STEM images. You can obviously work with one you prefer. Yeah, it will require something about a minute. Yeah. So after that, we can move to the image analysis tools. So as you remember, actually, it's kind of pleasure to give the hackathon after Cheryl's and Kamal talks. So as you remember, the agent is kind of reasoning core with the hands, so with the tools. So what we are going to do today, we are going to develop the toolset, or maybe extend the toolset for the agent to analyze STEM images. So the first one is just auxiliary functions. The second one is more interesting. So you may see there are some methods, some functions with tool decorators. So it's how you can register or create tools for the small agent. We already have a few tools available. You may see them. So it's a list of images. In our case, it's just 3 of them. It's the tool to load image, to get some basic statistics, make FFT, run some analysis, and etc. The noise image. What else is there? Yeah, enhance constraint. So you can just look through them. Yeah, then we just register, no, not register the tools, but rather create the tool list and can move to the next cell. In the next cell, some additional actions will require. So we are going to use Gemini as a reasoning core, and to send request to Gemini, to query Gemini, you need to get API key. So we use Gemini because Gemini provide free access. So to do it, just click here. It will be redirected to the API keys. you can just generate some API key here, copy it, then, sorry, a second, then come back to the notebook. Actually, there is instructions in the header, so you can click here, add a new secret. Secret should be called Gemini API key. Just pass the value and activate it. Yeah, and you need to click notebook access. In this case, your notebook will get access to your Gemini key. Then we can check it, and everything should work. Yeah, everything works. So after that, there is a cell with the agent itself. So the important part here is the instructions. So again, it will be very simplistic agent without some strict schema for output, but you may somehow to push it to provide you a more structured response. So yeah, you can go through this description, maybe to play a bit with it, to change it, to comment some of the part and look how behavior of the agent can work. And that's pretty it. So the agent is created here. It is a tool called an agent. You register your tools, you register your model, you have several additional parameters to play with. And let's try to do the first task. And first task is pretty simple. We just would like to load the image 0 and report the signal noise ratio. There is a special parameter which called verbosity level. So if verbosity level is higher than 0, probably it will provide you the inner reasoning loop, so you can see what were the steps and what were the reasoning why our agent query call one or another tool. Yeah, so after a few moments we get our final response. What typically user should see if you use verbosity level below 0. So it will be a scenario and some structured response, but it's structured in a mild way again. So it's not a strict schema, we just push it based on the instructions. So few more examples, something pretty simple, get the basic statistics. So it's nothing interesting actually, it's just load image, you may see on the first step, and then get image stats on the second one and provide you. So okay, let's try. Is it done? No, it's not done. Yeah. Yeah, so we provide you basic statistics. Let's ask something more interesting, more complex. For example, let's ask the agent to calculate the number of atoms on the image 0. What is the problem? The problem is that we don't have appropriate tool for that. Yeah, so you may see that first we load the image, second we make FFT analysis, then get the image state, and then we get the final answer. So in our final answer is the following. So based on the FFT analysis, the model defines the dominant spatial period on the image, and based on some assumptions, it can estimate the number of atoms. So probably this estimation is wrong, but what is important here is intent, right? So you may see that the workflow, that the path is actually pretty reasonable. Okay, that's pretty it. You also have some helper to inspect the image from the different results, from the different steps of the reasoning. And the task for today is just to extend the tools for this agent. So as you may see, for the last task, we couldn't estimate the number of atoms precisely because we don't have the appropriate tool, the tool which can be suitable for this task. So you may try to extend the tool set for the agents first to define all atoms, all atomic columns, calculate the number of atomic columns or define their position. And second, the second image is actually yttrium barium copper oxide, where you have different types of the atomic columns. You may try to extend, improve the agent, and try to solve this problem, meaning you ask the agent what number, what types, how many types of columns are present on the image, and it should return you some reasonable answer. So as you may see, it's also a quite open-ended task, and the main idea obviously is just to play a bit with it and maybe learn a bit about limitation and advantages of such approach. So that's pretty it. Happy coding. Okay, for 55, maybe somebody would like to share some results, some powerful tools, or everybody on the way. Yeah, by the way, it would be interesting to see your work if you will decide to submit it through the web form.